Let us understand about vector product of two vectors. Let us take two non-zero vectors a and b with angle theta between vector a and b. The vector product of two non-zero vectors a and b denoted by a vector cross b vector is defined as a vector cross b vector equals to mod of a vector into mod of b vector into sine theta dot n cap, where n cap is a unit vector perpendicular to the plane containing a vector and b vector. N cap can be either perpendicular upward or perpendicular downward the plane of the paper. Direction of n cap can be determined by right hand thumb rule. We have to find the direction of a cross b vector. Let us see how we will do it. When we have to find out direction of a cross b cap, we have to translate b vector towards a vector, keeping their point of intersection constant. Now roll your finger of right hand in the direction of b vector moving toward a vector. The direction of the thumb will give the direction of n cap. If either a vector equals to null vector or b vector equals to null vector, then theta is not defined, and we define a vector cross b vector equals to null vector. Definition: the vector product of two non-zero vectors a and b is denoted by a vector cross b vector and is defined as a vector cross b vector equals to mod of a vector into mod of b vector into sine theta n cap. Observations. Observation 1. We know that a vector dot b vector is a scalar, but a vector cross b vector is a vector since it has direction towards n cap. Observation 2. Let a vector and b vector be two non-zero vectors. Then we have a vector cross b vector equals to null vector if and only if a vector and b vector are parallel or collinear to each other. That is, a vector cross b vector equals to null vector. This implies a vector is parallel to b vector. In particular, a vector cross a vector equals to null vector, and also a vector cross negative of a vector equals to null vector. Since in the first situation theta equals to 0 and in the second one theta equals to pi, making the value of sine theta equals to 0. Observation 3. If theta equals to pi by 2, then a vector cross b vector equals to mod of a vector dot mod of b vector in the direction of n cap. That is, we can say that the modulus of a vector cross b vector equals to modulus of a into modulus of b. Observation 4. In the view of the observations 2 and 3, for mutually perpendicular unit vectors I cap, j cap and k cap, we have the following observations. I cap cross I cap equals to j cap cross j cap equals to k cap cross k cap equals to 0. That is, the cross product of a vector with the same vector is always 0. And similarly, I cap cross j cap equals to k cap, j cap cross k cap equals to I cap, and k cap cross I cap equals to j cap. This can be remembered using a circle rule. Let us place I cap, j cap, k cap in a circle in clockwise direction. Now, when we have to find out I cap cross j cap, we move in the clockwise direction and we see that the third one is k cap. But if we have to find out j cap cross I cap, we have to move in the anti-clockwise direction, giving negative of k vector. Thus, this formula can be remembered for other observations too. Observation 5. In terms of the vector product, the angle between two vectors a and b may be given as sine theta equals to mod of a vector cross b vector whole divided by mod of a vector into mod of b vector. Observation 6. It is always true that the vector product is not commutative, as a vector cross b vector equals to negative of b vector cross a vector, where a vector, b vector and n cap form a right-handed system, that is, theta is transversed from A vector to B vector, while B vector cross A vector equals to mod of A vector into mod of B vector into sine theta into n cap 1, where B vector, A vector and n cap form a right-handed system. That is, theta is transversed from B vector to A vector. If we assume A vector and B vector to lie in the plane of the paper, then n cap and n1 cap both will be perpendicular to the plane of the paper, but n cap being directed above the paper while n1 cap directed below the paper. That is, n1 cap equals to negative of n cap. This gives A vector cross B vector equals to negative of B vector cross A vector. Property: distributivity of vector product over addition. Let A vector, B vector and C vector be any three vectors. Then we have A vector cross B vector plus C vector equals to A vector cross B vector plus A vector cross C vector. Also, lambda times A vector cross B vector equals to lambda A vector cross B vector equals to A vector cross lambda times B vector. If two vectors A and B are given in component forms A1 I cap plus A2 j cap plus A3 k cap and B1 I cap plus B2 j cap plus B3 k cap, then their vector product is given as A vector cross B vector equals to matrix of I cap j cap k cap A1 A2 A3 B1 B2 B3.